Okay, let's jump right into this explainer on the Solid protocol and the absolutely massive technical effort underway to completely redesign how personal data works on the internet. We're looking at a project that has the potential to fundamentally flip the script on how our digital identities are managed, stored, and shared. Because let's be honest, right now, the foundational architecture of the internet is practically broken when it comes to user agency. We generate exabytes of data every single day, yet we own almost none of it. Solid proposes a radical infrastructure shift to actually fix this, and it's a concept that absolutely demands our full attention.
To really understand where this is going, we kind of have to look at where it started. Sir Tim Berners-Lee, the actual inventor of the World Wide Web, was devastated by the data silos of the modern web. There is a deep, frustrating irony here, right? The very guy who built the internet as this decentralized, open space for academic sharing had to sit back and watch it become a series of incredibly profitable walled gardens. That realization sparked a mission. Honestly, it's more like a rescue operation, to return data ownership directly to where it originally belonged, to you, the user.
So the crucial point here is that right now, tech giants hold the master keys to your digital life. Every single post, every like, every piece of personal information you create is stored on servers that you do not control. Think about how this actually plays out in the real world. Proprietary algorithms decide exactly what news you see, what products you buy, and what connections you make, entirely based on profiling data that is locked away in their corporate vaults. It's a fundamental power imbalance. Solid aims to solve this by completely decoupling the apps you use from the data those apps generate.
So here is our roadmap for today's explainer. First, breaking the data silos. Second, the birth of the Solid protocol. Third, the great authorization debate. Fourth, solving the querying bottleneck. And fifth, privacy and GDPR compliance.
Starting off with Section 1, breaking the data silos.
So, Solid literally stands for social linked data. And at the very heart of this protocol is something called the pod. Picture a Solid pod as your own, highly secure personal digital locker. Instead of handing a social media company your private photos or, say, your medical records, you store that data safely in your pod. Now, for the developers out there, it's vital to understand how much this changes application architecture. In the Solid ecosystem, applications essentially become empty shells. They bring the user interface and the processing logic to the table, but you bring the data. You grant an app access to specific data points in your pod via an API, and the exact second you want to revoke that access, you just flip a switch. The app is instantly cut off, and you haven't surrendered a single byte of your underlying data to them.
Moving right along to Section 2, birth of the Solid protocol.
Now, this vision didn't just appear out of thin air overnight. We're talking about an idea that started way back in the year 2000 with DARPA-funded semantic web experiments over at MIT's computer science labs. The goal back then was to create a web of machine-readable data, linking concepts together so computers could actually understand context, not just match keywords. Fast forward to 2009, and Tim Berners-Lee was heavily pushing this mantra of a read-write web, a web where users didn't just passively consume documents, but actively authored and controlled their own nodes of linked data. But, academic research can really only go so far on its own. Recognizing that a massive commercial push was needed to actually build out the infrastructure, a company called Inrupt was founded in 2017 to create enterprise-grade Solid products. That was the catalyst needed to pull this tech out of the lab and start pushing it toward mainstream adoption.
Which brings us to Section 3, the great authorization debate.
Because think about it. Once you give users total, absolute control over their data, you have to decide exactly how they are going to manage that control. And right now, developers are in the middle of a massive debate between two competing authorization standards for Solid. On one side, we have WAC, or Web Access Control. It's a simpler Unix-like permissions model. It basically just assigns read, write, or control Booleans to users and groups operating on a really strict deny-by-default mentality. On the other side, we have ACP, or Access Control Policies. Now, ACP offers highly granular, heavily customizable rule-based permissions. The friction here is that these two systems are largely incompatible at a core architectural level. You simply cannot easily map a complex, multi-conditional ACP logic rule back into a basic WAC read/write permission without either losing all that nuance or just flat out breaking the system.
And we really have to stress that the stakes for getting this right are incredibly high. If an average, everyday user misconfigures a highly complex ACP rule, who's responsible when their sensitive health data or financial records leak to the public? Some users in the developer forums have rightly pointed out that applying incredibly complex access rules to our fundamental digital identity could lead to some disastrous unintended consequences. Because when permissions get too complex, human error is basically guaranteed. When we are dealing with deeply personal data, applying that old Silicon Valley mantra of move fast and break things is outright dangerous. So the community is working tirelessly right now to find the precise balance between bulletproof security and actual everyday usability.
All right, let's look at Section 4, Solving the Querying Bottleneck. Beyond security, there's another massive hurdle the project has to overcome, and that's the sheer computational nightmare of querying data. Imagine a standard social media app interface on your smartphone. In our current centralized world, the app executes a single, clean query to one massive database to retrieve your posts, your comments, and your likes. Simple. But in the decentralized solid ecosystem, we run headfirst into the N+1 query problem on an unprecedented scale. A single post might live in one user's pod, the comments in 10 different pods, and the likes scattered across 50 more. If your phone has to individually resolve and fetch data from a million different distributed pods just to load up your morning newsfeed, the latency would be insurmountable. The app would literally just hang and crash.
To fix this crippling bottleneck, researchers are designing what they call network aggregators. You can think of an aggregator as this incredibly intelligent caching layer that sits perfectly between your client application and the vast network of scattered pods. Its entire job is to do the heavy lifting so your phone's processor doesn't melt down. It maintains an up-to-date, materialized view of the data across all these various decentralized sources. Essentially, it pre-assembles all the fragmented pieces of the puzzle in the background so that when your app requests the data, it queries one organized source and gets it instantly.
This all happens through a highly structured three-step process. First up, the aggregator finds the scattered data using something called link traversal. Since Solid is built on semantic web principles, data points are connected via URIs, forming this massive, interconnected RDF graph. The aggregator literally follows these URI links from one pod to the next to discover related data. Second, instead of brutally re-downloading the entire internet every 5 seconds, it tracks changes incrementally. It only updates the specific data points that have actually been modified. Finally, it continuously updates that materialized view. This brilliant piece of architecture means your app gets its feeds updated in real time without fetching the entire web every time you swipe down to refresh.
And that brings us to our final section, privacy and GDPR compliance.
Because, at the end of the day, all of this brilliant technology still has to navigate the strict, real-world reality of European data privacy laws. What is truly remarkable here is how elegantly Solid shifts the burden of GDPR compliance. Under this protocol, the data subject is you. You own the pod. The pod provider just hosts the infrastructure and acts completely blind to your actual data. They are essentially just the landlord renting out the server space. The app that is trying to access your pod, that's the data processor operating under a specific legal basis, like your explicit, granular consent. This is a massive, transformative selling point for software developers. By entirely shifting the data controller burden back to the user, developers can build incredibly rich, personalized apps without inherently taking on the massive legal liability that usually comes with hoarding user data. It strictly separates the technical plumbing from the actual data processing.
So here's where we land. Solid absolutely gives us the exact tools we've been asking for to escape corporate data silos and reclaim the architecture of the web. But as we fight for digital sovereignty, are we truly prepared for the complex responsibility of being our own data guardians? Will everyday users actually have the technical literacy and the patience to securely manage their own access control lists? Or will we inevitably just seek out new centralized platforms to make it easy all over again? It is a thrilling frontier, and how we as a society answer that question is going to define the entire next era of the internet. Thanks for diving into this explainer with us.